For this problem, we have the following verbal representation. A ferret walks 2 meters in 4 seconds, stops in stunned silence for 2 seconds when it sees you, and immediately turns around and runs in the opposite direction. So I'm going to start with a pictorial representation. I have this animal that I can't draw, but it's moving leisurely pace, a couple meters, to which it then sees you, is scared, and runs away, and quite a bit away. So here's 2 meters, and then runs, again, not to scale, 10 meters in the opposite direction, much faster. All right, but I have an idea of what's going on. So now I want to turn that into a schematic representation. So I'm going to represent my ferret with a dot, and then 2 meters, it stops, 2, and then it runs the other direction, some much longer distance, another 10. This would be an 8 meters on the other side. So I need a coordinate system with my schematic. And a coordinate system has an origin and a positive direction and a variable associated with an arbitrary position. I'm going to put the origin of my coordinate system at the place where the ferret started. I'm going to have the positive x direction go to the right. Now I have a schematic representation of my motion. Next, I want to make a tabular representation. By tabular representation will be the position versus time. If I have time here in seconds and my x position in meters. So I'm going to choose my origin of time at the beginning, where the ferret started, and it's at location 0. So the first 4 seconds, 1, 2, 3, 4, it moves 2 meters, which means it's moving half a meter per second. It gets 1 meter at 2 seconds, half a meter at 1 second, and 1.5 meters at 3 seconds. It stops for 2 seconds. I'm going to have to get more space. Stops for 2 seconds in stunned silence. That's second 5 and 6 where it doesn't move. And now in 1 second, it moves 10 meters, so it goes all the way to position -8. So there is a tabular representation of my motion. I've made a graph with the horizontal axis for time and the vertical axis for position. Since I already know sort of the range of data given my tabular representation, I've allowed my graph to be able to cover the entire range. T is equal to 0, it's at the origin. At 1, it's half a meter. At 2, it's at 1 meter. 3 is 1.5, and 4 is at 2. 5 is also at 2, 6 is at 2, but 7 is at -8. So these are straight lines, so I can complete the graph by drawing those straight lines. My final one with a very steep negative slope. And I have a graphical representation of my situation. Here's a mathematical representation. I'm going to look at the 3 separate regions where my motion is straight lines. In the first one, the line of the position has a slope of 1/2 and a y-intercept of 0. The function that describes it is x of t is equal to 1/2 times t. In this middle region, it's simply a constant. It's at 2 meters. In the final region, I want to come up with an equation for the line that connects these 2 points. So I know it's a line, x of t, and I know the slope is going to be -10 because it travels 10 meters. It decreases 10 meters in 1 second. So the slope is -10t, and then there's going to be some y-intercept to this line, which I don't know. But I do know that it was at a location of 2 at a time of 6 plus b. So that's -60 plus b must be equal to 2, so that tells me that b is equal to 62. So I'm just doing some basic algebra here that tells me my last stage, x of t is equal to -10t plus 62. And now I have a mathematical representation of my motion.